Well, hi, and welcome to my shop this morning. Oh my gosh, we're going to start on this gigantic, big, square tube tester. Holy smoke. So a little bit of a background on this. I couldn't tell you where I got this. I can't remember how I acquired it. I've had it for a while. I've never really looked at it very closely. I've got other tube testers which appear to me to be better than this one, but maybe not. I've already done a little bit of research on this, and I may have underestimated the value of this particular tube tester. This is probably from the late 50s, early 60s, I'm going to guess. There's a chance that this was a kit that somebody bought and assembled. Just looking up here at the pointer, I see the pointer is you know, if this meter doesn't work, this whole thing is shot. So the first thing we got to find out is, does this meter work? And I see it's way below the zero. So before I even spend any more breath, let's just turn this a little bit and see what happens. So there we are. Perfect. So that's great. So that proves a fair bit about the movement right there. We don't know for sure it works, but mechanically it appears to be just fine. Whew. Okay, we jumped the first hurdle already. So I'm going to look this guy over. You'll see some knobs are missing. That's me. I've taken the knobs, I've put them on other things. I was actually so unconcerned about this. It's kind of ugly, you know. It just didn't turn my crank. But like I said, having read up on it, I'm thinking a little differently now. Precise Development Corporation, Oceanside, New York. Now, there's a serial number spot here. There's no number. Isn't that interesting? They did not actually put a serial number in there. The paint on here is elevated. I can feel it with my finger. So let's look for a very popular knob. A popular knob would be one that gets adjusted a lot, and you're using this. And you know what? Just about any knob would do it. So I'm looking for wear from use. Looking for the worn down numbers. I don't see really any evidence of a lot of wear on this thing. Yeah, it's pretty good to start off with. It's got some interesting tube sockets. These are quite modern tubes, right in the sort of the last gasp of vacuum tubes. I've got nothing that would plug into either one of these, but it has them. That kind of dates this. So there's the 9, 7, 4, 1, 2, 3, 4, 5. They're all here, and of course great. It's got a short light indicator here. Gas test button, something I need to get a little better on. Life test button here. A fuse light, kind of hidden in behind here. Off, test, hold. Let's see, this button's labeled test. Spring loaded, or you can click it on. It's got listed right on it. This is another thing that's quite interesting. It actually gives you what each of these controls is doing. This is a GM EM. Okay, so GM is mutual conductance, transconductance. EM? I'm not sure what that is even. And I see the meter is calibrated with GM, GM, and EM. So there's a factor there. I don't even know what it is. Filament, voltage, plate shunt value. It puts it right on here. 3K, 6K. I mean, this is quite interesting compared to other tube testers. Screen volts, plate volts, EM shunt. So again, I'm really not sure what this is. This is the short testing control with the knob missing, and it has 10 positions. Probably 10 positions for 10 pins. I don't know where you find 10 pins up here, but 1, 2, so you probably just snap this through here and it looks for shorts on each pin. That's probably what's going on. There's a noise. I believe the way you use this is you would hook up a AM radio with an external antenna lead to this. And then noise coming from the tube under test can be picked up and heard by the radio. I think that's the theory with this. This is for a grit cap, plate cap. I noticed the caps are missing, of course. of course. Reverse on the meter. Yeah, this is really pretty good. I kind of like it. What's the labeling down here? F, G, H. So these are just letters to relate back to the instructions down here. How about that paper? Is it going to rotate? Now usually you can find these charts on the internet. I see this one. The paper is all worn out just over here. It's been damaged and kind of. So assumably I can get not only this roll chart, but even more up-to-date roll charts that might have been produced after this thing was first manufactured. Cord comes out the front. That indicates, and the way this is built, you could take it out of its tin can and you could mount it on your panel somewhere. Like I could mount this, right in this space and just screw it in with a few screws. I could have this just permanently sitting right on my bench. See, that's an interesting idea, but I don't have much real estate. Look at this thing. Oh my gosh, it takes up a huge amount of space. So if you were, it comes with a leather handle, which is of course broken away now, but if you were a repairman, would you really want to lug this thing around into people's homes? You would be doing that. Let's see. GM in the thousands, it says here. Model 111. Not too much information. Let's look at the back. I think there's nothing much to see here. It's just a big metal box. It's got all its feet. About to lose one down here. Yeah, have to tighten it up some other way. A couple holes in the back here, but looks like maybe a screw is supposed to go in there. I'm not sure. Well, I don't think I'm just going to plug this guy in and see what happens. Let's look at the power cord. It's gotten pretty stiff, especially right in here. It's gotten quite stiff. Quite stiff. But still usable. We don't want to be bending it too much right in here, that's for sure. Or should I plug it in? Shall we plug it in? Just plug it in and give it a go. What is the concern here in doing that? Now, I have a way of plugging it in, of course, using dim lights to protect things. Sure is tempting, but I think the smart thing to do is take it out of the cabinet and take a look at it first. But I just, I love just check it, just plug it in and see what happens. So these screws, I'm guessing, are not the originals. They just don't look right to me. You know what? These are quarters, I believe. This has hit the deck here on the corner. It's all bent up here where it's been dropped. Probably me, because I have not taken care of this at all. Shameful. Because right off the bat I've underestimated its value. Oh. I don't want to underestimate its weight. Lift it straight out, and then what? So I think what I'm going to do is I'm going to put this down on the floor here and then pull it out of the cabinet. Here it comes. Oh baby. Put it right on its face. Oh baby, baby. Wow. Yeah, man. this is somebody's kit, they must have just burned their brain out working on this thing. Oh my gosh, look at that. Woo-wee. This does not compare to the last tube tester we were just taking a look at. Oh my gosh. So what do I see? First of all, is this a factory built machine or is this a home built machine? It's not necessarily really easy to tell, because a home builder can do a pretty good job. Why don't we get the close-up camera going here and we'll look through this thing quite closely. At a glance, looks pretty good. We'll switch cameras here. I'm gonna hand hold it. Let me set the focus up for where it's going to be good for us. Not too close, not too far. Just about like that. Okay. So let's follow the kind of the power. Well, that's why this thing is so heavy. It's got two great big transformers here. You know, I'm going to change the focus just a little bit so I can be back a bit further. There. Wow, look at that beast. This almost looks like it was factory built in the factory that this whole machine came from. Okay, look at this nicely done wiring here. Look, all labeled down here. Pretty nicely done. Get it up in here. All numbered and labeled. Or so, you know, if this component is defective, then again the machine is probably lost. Same thing with this. So I'm just looking at them fairly closely. They didn't bother with all this extra stuff on this one. What would the difference be? Could be a higher voltage here. Why would they do this? They only did it on these leads. They didn't do it up here. This blue, what I assume is shrink sleeve of some sort. Yeah, it's definitely shrink sleeve. This one is shrunk incorrectly. It's shrunk up too high. Or just shrunk up higher or something like that. I don't know. I'm still asking myself. Hand built or built professionally. You know, I would say this is professionally built. I would say this is a factory job. So it's this big bank of resistors here. Let me turn the camera around so we can read them. Well, they're all just 10% resistors, nothing particularly. 295, not 300? Really? 295 at 10%. So that's plus or minus 15. Why not 300? Okay, so capacitor. A couple higher wattage resistors here. Look at all, I just realized, oh my gosh, look at all these adjustments here. Oh my gosh, look at them all. That other tube tester I just finished doing had nothing in it to adjust. And this one, look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 adjustments just on this panel here. Hey look, here's these two screw holes that are supposed to have screws in it from the back to stabilize this panel. It's pretty stable anyway. That's a this is actually one piece of metal from here up here. This is one piece. It's just got a bend in it. So this is really very, very secure. Okay, I hate to do this, but let's just look at some of the wiring down here because there's so much of it. Some color coding going on. Now, assumably what they did here is they took pin 1 of every one of these sockets, and pin 1 is wired together and then brought to the front panel somehow. So that's assumably how these are built. So what do we got here? So these are the terminals where you're putting in the grid cap. Switch there. Looks like a capacitor. It might be a resistor. Okay, lots of components here. All these switches here, any one of which could be any one or all of them could be quite dirty. I'm probably going to have to make some effort at cleaning these. You can see the center ring is just black. Maybe this hasn't been turned in 20 years. Let me turn that control. I'm going to reach under here if I can. Okay. Oh well. Who's to say? Maybe some testing before fiddling with these. A little bit of testing might reveal if these really require a lot of attention. They may not. They may not actually. You know, that one you can see the skid mark quite clearly on the one I'm looking at. I don't think I've turned the controls at all, other than what you just saw me do now. What else we got here? We got some big value resistors here, big wattage resistors. 500, still 10%. There's another one there, 500 ohms, 10%. What I'm worried about is that there's 1% resistors in here. Now, oh, here we are, 1% tolerance. And what is it? It's a resistor. Stuff like that. See, 41 ohms, 1% tolerance. Well, I don't have a 41 ohm resistor, although I could make it up. Look at this one. Look at this. 38.83 ohms? Really? How can I have a 1% tolerance and they're showing the resistance down to 2 decimal points? How does that work? So there we are. Anyway, I have found some resistors here to be a little bit concerned about. There's a light bulb back there. I think that's the power light bulb. Okay, great big capacitor right in front of me here. We'll get rid of that. As soon as I learn how to move the camera. Impregnated. Oh, that's right, impregnated. That reminds me. I am a grandfather now. As of yesterday evening. My first grandchild, a girl. Pretty exciting stuff. Everything went fine. So these look like precision parts too. Maybe not though. This is around a light bulb. Maybe it's not so much. We're getting right under this great big tube here. Yikes. Okay, well, I'm going to guess that's the rectifier tube. That's a big honking tube. (5U4). It's pretty new. That's a pretty kind of new looking tube. That's like the nicest 5U4 I've ever seen. I gotta use 2 hands on it. Okay, now the other tube and a little transformer here. So what exactly is going on with these? I don't know. Let's pull it out. Made in USA. General Electric, what is it? 6x4. That's another rectifier tube, isn't it? 6x4? Not exactly sure offhand. Well, now we continue on past this endless row. Look at this. Oh man, how would you like to... Oh, there's a problem in there somewhere. I hope not. And at the far end of the machine we encounter another capacitor. .25. That says 25 volts DC. Yeah, there it is. Microfarads 25. What? Must be way over here somewhere where the capacitance is written. Anyway, won't worry about it. Really, I don't need to see what it is. It's gonna go though. Okay, last few things to look at here. Bunch of resistors there. There's a wire wound rheostat. Oh, that looks just fine. This is probably the line voltage control here. And the light bulb. Well, you know what I would say? I would say we should turn this guy on. For sure. Just as it is. Why not? What bad thing could happen because we turned it on? Not too much. Can I just flip it over and let it sit on itself? It'd be sitting on this, which is really good, and potentially sitting on these two corners here. You know what? I can probably do it. Let's try it. Flip it right over here. Oh, it's pretty flimsy when it's just this front panel. Oh, it's going to be upside down like that. I got it on the cord. So it sits quite nicely like that. So we will accept that. Now I don't have knobs on some of these things, so let's see, this is the meter select control. This is the short test, bias filament test. Where's the on-off switch? That's really what I'm after. Bias high-low, line adjust. Should be a nice big on-off switch on here. This must be it here. Off, life, on. No, that must be it. Okay, is everybody ready? I'm not quite ready yet. Okay, so first thing we're going to try, let me just back this camera up a bit, give you a little bit of a bigger view here. So all the power that's going to reach this from the 120 volts line is going to go through this 25 watt light bulb. This will restrict the amount of power that can get here. If there's something seriously wrong in here, this light's going to come on full tilt, and we're going to know it right away. So what I'm hoping I'll see is this light will come on pretty bright, and then it begin a dimming process within seconds. That's what I'm hoping. Okay, so we're gonna, there's no power supplied. I'm gonna flip this, well, let's leave it off, and we'll apply power and make sure off is off. Sometimes off is not. So this pointer has gone upscale, probably because I laid the machine flat. That's probably why the 0 is wandering, flat or standing up. That's probably what's happening there. Anything else we should look for? The pilot light should come on if the bulb is good. The meter may do some deflecting, which I'd like to see initially. That would tell me the meter's good. Really nothing else should happen here. Okay, I'm ready. So my eyes are on the light, but it's, the reason I use those light bulbs is that if they come on full blast, you don't have to be looking at them to know it. This is really actually a very good way of doing this stuff. Here we go. Excellent. So nothing happened at all. 123 volts on the outlet, just because the switch is off. Excellent. It's great. It didn't work. Excellent. We'll flip it on. Just skip this light setting here. This time this light should come on, and who knows what else. And this light may come on and go. Here we go. Okay, I'm watching this light to go dim. Watching the meter. Light. The light does not seem to be changing. Okay, it doesn't look like it's full brightness to me. Yeah, pilot light has come on. So that tells me the output of the power supply transformer is not shorted right down. There's something coming out of it. So that's good too. I don't hear anything. I don't smell anything. I have no idea if it's working. So let me look under here. Actually, let me grab the close-up camera. We'll take a look underneath, see if the tubes are lighting up in it. Bear in mind, I haven't checked the chassis yet for dangerous voltages. So this is the high voltage rectifier tube. It's usually pretty easy to see the filament in these guys. Right down the top. Just the blue light of the camera shining back in my hand. How about the other one? I'm going to shut the lights down in my shop here. Now we're still running this on restricted power, so now I run that much greater of a chance of sticking my hand where I shouldn't. So with my own eyes, I would say neither of these tubes are lit up with my own eyes. So I don't see anything in there. How about this big one here? This doesn't bode very well for this machine. So how come this tube's not lighting up when in fact the pilot lights are on? I'm taking a real good look with my own eyes here. I think we're not on the tube heating. Okay. Bring in some light. Okay, with it still sitting here, switched on, pilot light's definitely on. Now this is plugged into an isolation transformer, so there's really little or no chance of this light coming on here when I do this. But I'd still like to do it. What do you do? Stick a tube in it and see what happens? I can't imagine. Is there another switch on here that is stopping the heater from heating? None of these. Fuse light is not on. Now, my impression with these guys are you turn them on, the tube, usually it's only one tube, the tube or tubes inside will come on and heat up and wait for you to do a test. They're not dependent on any switches up here. I think that's a real fault in here. Fault in the heater circuit going to the rectifier tube. It doesn't sound very good to me. I think the next stop is, whoop, got the power. Next stop is to look at the schematic and try to sort out what would have to be amiss that these tubes aren't heating. And you know what's possible? The tube itself is defective. The tube heater element's burned out in it. Both tubes? Not so likely. Let me flip this over now. What about one of those capacitors causing this kind of problem? Can't see it? Really? Can't see it at all? Is there a... wow, you tipped this over. You really bend the power cord here. Right in here. So let me leave it hanging over the edge of my bench here. There we go. Okay. Power's off, but let me pull the plug out too, just to be doubly sure. Okay, I think we've seen enough of the beast itself. Let's check out the schematic here. Okay, so question is, why would the heater not go in this tube? Okay, possible reasons. One, I never put this on full power. The tube, the light bulb, the 25 watt light bulb, a fair bit of light coming out of it. Meant it's dropping a fair bit of power. Never looked at the voltage actually reaching the unit. Could be this didn't glow simply because I restricted the 120 volts too much. Let's take a look at what's going on down here now. Oh, here's the two transformers here. Look at all the different secondaries on this. Oh my gosh. And this will be for the heater. This will be the heater one, will it? Rotors, internally. Dummy lug, tie point. Look at this. TP indicates a dummy lug on a switch which is used for a tie point. Now this is one of the most confusing things when you're looking at electronic stuff, where there can be components with lugs that are spare. And the designers and builders use those as simply points to attach two wires together without actually making a contact to the device. It's very confusing for anyone to look at. So they actually wrote it right in here and actually indicate where that's occurring. That's another sign of the quality of the engineer who designed this stuff. So now in this point I'm thinking, this is really the tube tester I should be working with. This is really the all the signatures down here. Let's take a closer look at that. Where I once was a drafting supervisor, even though I was never a drafter. Drawing number, project. There's the guy's name who's in charge of the whole thing. KQ, who knows? Bellinger? I don't know. There's FAR, drawn by. So this is the technician who drew this diagram. This is probably the engineer who checked it over. Here's the actual design guy. Drawing number, date 64. I think that says 64. So they have a project leader, a designer, probably an engineer, a draftsman, and exactly who this is. He could be the supervisor of the draftsman or something like that. I think it's kind of neat. You see, one of the things that's missing in our world is our ability to express ourselves as individual human beings through our work. The modern work environment that's been around now for 150 years or so, the industrialized work environment, takes your human effort output and rubs it clean of anything that has to do with you. So when the car comes off the assembly line, there's no sign in it that you had anything to do with it. And this is a missing element in our economic system. As crazy as it sounds, I firmly believe that if each individual could somehow get their name onto the final product in some way, shape, or form, we'd all feel a lot better about the world and what we're doing in it. And that's what these signatures are all about for me. This is where human beings are brought right out. Look, it's not just their names, it's their handwriting. It's their handwriting in here. You don't see much of that anymore. Okay, so I am going to relax now, calm down. It's just one of those things. So now we want to go back to why is this tube not heating? I think the best bet, because it's just straight onto the winding here, the best bet is, what's the center tap doing here? What's this doing here? So this, of course, is where the negative return or positive supply comes out. Look at that 0.01 right there. Because it not only is the heater energized by this coil to heat it, it's also got the entire DC output of this tube, or product of this tube, going through it on this wire. Typical, it's just normal stuff. And what's that? This is probably one of the internal adjustments that needs to be made to set up a proper voltage here or something like that. Ooh, my God, I just hate going through switches. Look at these things. Look at these. Oh my God. So fat chance I'll ever figure out specifically how all these work. But generally I can probably get a pretty good idea. Holy smokes. This is one complicated machine. Compared to the last one I looked at, the last one was as simple as they could be. He even said that right in the manual. It proudly proclaimed it to be a very, very simple tube tester. And what it said was its simplicity made it easy to accommodate newer tubes that were coming onto the market, which of course was a challenge all the time for these tube testers. I mean, as soon as a tube tester came on the market, there were tubes it couldn't test. That wasn't in the chart. So, okay, I'm just going to turn this thing back on again after all that. I'm just going to turn it back on again. I'm going to leave it upside down this time. And we're going to watch for this tube to heat up. I'm going to give it full unprotected power. Well, we'll see what voltage is coming to it. So I think I left it on. We'll know if the lights come on. No lights. I left it on, but I didn't leave it plugged in. Let's plug it in. I'm a little more. I'm getting a little excited about this machine now. Okay, lights on. Supply voltage. It's only 45. Look at. Probably not enough to make this heater hot enough for me to see it. So we're gonna heat things up here. First, what I'll do is I'll screw in the second bulb. This will raise the supply voltage quite a bit. We're at 50 volts right now. Quite a bit is right. We're at 104. So I'm staring very intently at this bulb, which was glowing ever so slightly. Like it's glowing now. It seemed to me it was doing this, but you know, could just be me. Could just be me. Now, did this guy heat up? I don't think it's heating up. I don't think this tube is heating up. Now you got to be very careful because there could be high voltage sitting here. There is high voltage sitting on this tube coming out of this transformer. What appears to not be coming out of it is the wait a minute. Hold on. I do see something. I do see this tube is heating up. Thumbs up. So it's just a question of giving it enough juice. Because I still have these bulbs in the circuit. If something were to go wrong in here, or a short circuit develop, the bulbs would brighten up right away. I'm going to leave them in the circuit. They're only trimming 10 volts off the line voltage. We're at 110 roughly. So now I think what would be cool is try testing a tube in it. Because nothing seems to be going terribly wrong. Okay, power off. Oh, roll chart. I'm not sure. Let's see. Yeah, it's rolling pretty good. Okay, well, let's just do what I have available. 12, AU7. Find a 12. Where's the 12? That's the problem with these roll charts is you never know where. You never know. Ooh, so there's the end one way. often the roll chart is on a wooden dowel, and the edge of the roll chart is just scotch taped to the dowel. The scotch tape dries out and gets out. You can see it here, and so it loses its connection to the roller. This one appears to still be okay. 12. Oh, what's that? That's a joint in the roll chart. Oh my gosh. So this is 2 pieces of paper, and they appear to be just taped along the back. Yikes. But I think I did see extra, like roll charts. It's all this. Wow, this is really, really fragile. So this is the problem now. I'm at 6. I'm trying to get to 12. I think 12 is probably at the top of this side. Sometimes they would write the limits on here, but I don't see them written. I gotta watch I don't stick my... Is this still on? Are we still on here? No, I'm not on. But while I'm doing this, I can easily get my fingers going underneath. I gotta think about that. Okay, we must be getting towards the end of the roll here. We are. Okay, it didn't show up. So unfortunately, it's going to be at the top of this one. What do we got here? We've got 802, CK 507, never heard of that. How about a 99? EL84, number 80, number 76. So it's got all kinds of things on it. Old and new, 56. Okay, let's just shoot down to 12. 12A. Right at the end here again. Paper's really tightening up on it. It's going to be right at the top. Oh my gosh. This is what is wrong. This is the bad thing about these rolls. Even me helping it underneath, it's not going to go. Okay, so let's take a look at what I've got on my computer here that might help. Okay, 1959. This would look like the right kind of thing. RC111. What's that? Does it actually say what machine it's for? So what we'll do is we'll go up to where I've got a 2E41 showing on the actual roll chart. 2E41 right there. 2E41 1.1 volts, 0.01 amps. That's exactly what it says. CGAG. 2E41. Lost it there. CGAG 34061. 50,000, 4.9 volts, 264 and 6. Yeah, it's exactly the same. This is exactly the same roll chart here. So, you know what? I think this is probably my best tube tester. Okay, going for 12, 12, 12. Stop, stop. 12 AU7. Here we are. Okay, one. It's like one setting. Oh, I don't know how to use this. Yeah, I can probably figure it out. Now wait, one setting, it's got 4. 1, 2, 3, 4. GM, GM, EM, EM. 1.5 amps. Do you actually can you read this current on the meter? Is that why it does that? 12.6. Okay. Well, I'll leave this on my screen, but on your screen. Okay. So it says 12.6. Oh my gosh. I'm at a dead stop. There is no flat spot on this. This is really not... Okay, so I'm trying to do this quick and dirty. This is quick and dirty. feel it. Turning. It's turned up pretty high. Okay, so I'll put this on here. It'll be pointing at the first setting of 0. B, 0.6, 1.1, 1.5, 2, 2.5, 3, 3.5, 4. Whoops. Something didn't work there. 0. B, 0.6, 1.1, 1.5, 2, 2.5, 3, 4.3, 5, 6.3. So that'd be the 6.3 setting there. But I don't want the 6.3 setting. I want a higher setting. 6.3, 7, 10, 12.6. That's the 12 volt car battery voltage. So we got that on 12.6. I'm not afraid to ruin a tube here. Next thing is 12A7 C G G G C G G G C G G G, and then it has a dash. The dash must represent this control, and I think what it's indicating is it's immaterial. That's what I think that means. And the next row, B E B D. So B, no, these are numbers. Boop, 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 boop. Okay, I'm doing this wrong. Okay, so the numbers would be 0, 0, 2, 5, 6, right? I'm learning. 0, 0, 2, 5, 6. 0, 0, 2, 5, 6. The lower number is 4, 1, 2, 0, 0. 4, 1, 2, 0, 0. Now, what about this first one now? The first one is supposed to be 4, 1, 2, 4. 1, 2, 3, 4. Okay, that's on 4. So these are set correctly. Next thing along is bias at 3 volts. So this must be an attempt to actually read the voltage. This is a scale selection. So on the 10 volt scale, there's no 10 scale here. It's just a 5 scale. I guess you got to use your arithmetic at that point. So you just I guess you double all these. There's a lot of guessing going on here. So that would be 3 volts. Now with that fantastic precision. Ooh. Pretty terrible precision here. Three. And the next thing is shorts. What's it say there? 12A7 short 459. 459. So here we are. So you do 4, 5, and 9. Short, that means you expect to find shorts on it. Now I know there's no shorts in these tubes because I've tested them on other testers. That's not going to work. it's just to keep going around? Oh, no, don't do this. Oh, how am I going to figure out... So there should be a divot where the old knob screw was tightened. The screws are on the back here. So you should put a mark on the thing here. Let's take a look for the mark on the thing. Mark on the thing. Let's get a little closer to the topic here. So we're looking for the indentation of the locking screw on this shaft. I think it's around this way. I'm having a very hard time doing this. So I think I see a definite scratch in there. Well, that kind of looks a little like it. The thing is, when you lock down the screw, not only is the screw jammed into this, but the opposite side from the screw is jammed into it. Could put those cut marks in there. Let's go on the other side and see if we see a circular. There's no marks anywhere but on that one area. Oh. Just a little trouble with the lighting here. I see a very clear circle now, right above my nail. Right straight on this way. It's the same thing. So we're going to say those, wow, they just don't look right. I thought I saw a circle. There's a circle. There's a circle. That's got to be where the screw tightened down on it. So with that where it is, this thing is, assuming I got this right, it's pointing at setting number 1. We're off test by only one click. Okay, let me click it. Where's my big tool here? Well, I guess if this is in the wrong position, it'd just be sitting in the short test. It'll become pretty apparent fairly quickly that the machine's not really working. Okay, give me some light here. Get out of the light. I think it's on test. That's my best deduction is I have this set to test now. What about the meter setting? Line bias test, straight up. 3 amp, 0.3 amp. So this must be where you're reading the filament current. You set it here. I'm going to guess. I don't know what you're reading there. Haven't read the manual yet. We'll set it for line. Okay, it's set on line test right now. I never made this bias adjustment, did I? Did I do that? Bias, yeah, I did that. Sure, I did that. 3 volts, that's right. Yes. 12AU7, double check everything. 12.6, yeah. C, G, G, G. C, G, G, G. Dash. 1, Well, whoop, wrong tube. 00256. 00256. 41200. 41200. Yeah, I remember. I think this is on 4. Three, 2, 1, 0. That's the end of the road. 4, no doubt about it. Okay. We're on line here. We have to go. Well, maybe what you do is I think I know what you do here. This bias thing is not calibrated. You set this to bias. You then adjust this until you get your 3 volts up here. So I'm still just trying to find out if this meter works. That's really the purpose of all this, just to get the meter to go upscale. So if that's the case, then you want the bias adjustment not on 30, but just low to start with. Check the line, check the bias, then you're ready for the test. That kind of makes sense, doesn't it? Normal meter. Now, how does this work on the meter with the line setting? The line, usually there's a mark. Filament amps, right at the bottom. 3 amps and 0.3 amps, so that's for sure what this is. Then just above it is a bias, 1 to 10 volts, and 0 to 50 volts. So that's definitely what's going on here. This is not a calibrated adjustment. Then you're ready to read GM or GM on these 2 scales, or EM on this very, very top scale, whatever EM is. Where's the line adjust? I see no line adjust. No line adjust indication. Here's the line adjust control. It just says line adjust. Look at that. Well, what am I adjusting it? I must have missed something here. Let me change the focus on the camera. Hold on a sec. What did I miss? Somewhere there's a little something for the line. If I were engineering this, I would make it come right in the middle. Somewhere where that question mark is. Or look at this scale. Okay, look how right in the middle. 10, 4, 3, 1.5, 25, 5. They all line up. Just the 1.5 doesn't quite line up. It's another sign of an engineer who's really got his shorts in a knot. Well, I don't see anything. Am I crazy? How are you supposed to adjust this if you've got nothing to adjust it against? So there must be something written in the manual that says something like adjust it so it's straight up or maximum something. We'll find out. Let's find out. We'll find out. Oh boy, are we going to find out. We are going to find out. So it's hard, but I can turn this. I do have some more knobs to put on these things. I will get them out and get them on. So we'll set this about the middle here, roughly. Not quite. Just looking to see if I missed a 120 volt scale on here, but no. I think we're ready to power it up again using 2 dim bulbs. It's going to give it pretty much drawing a pretty good chunk right now, but you can see it going down, down, down. So the big draw could have been tube heaters, drawing power. There's only 2 tubes in here, but okay, so now we want to do the line adjust. So I have this switch to line. Here, I have this, back up a little bit. So I have this switched to line. So what? What? I'm not going to be able to figure this out. Nothing. That's the wrong control. Anybody moving anywhere? Watch your fingers, man. I tend to get my finger underneath here. Well, I'll tell you one thing. I can see this light going up and down as I turn this. So it's definitely having an effect, but this is the meter. This is the meter set. This is the meter switch. I've set it to line, so the meter should be showing us the line. Oh, you know what this is? You know what this is starting to say? The meter doesn't work. This is starting to say the meter doesn't work. Okay, we got to take a more direct approach to finding out if this meter is good. I'm going to waste more time here on this guy. Let's pull the plug. See, I'm disappointed now. Let's flip this puppy over. Whoa! Yeah, there's certain disadvantages to having a rotating platform on your bench. Okay, where's the meter? The meter's hidden up under here. That meter, it's got a great big capacitor across it. How am I going to get in there? So voila, another big capacitor shows up. This might be as a damping capacitor for the meter, because it looks like it's right across the meter leads. Sure does. Why can't we just put a little voltage on there and see the meter move? We just want to make the meter move. So I'm going to put a couple of clip leads around across that capacitor, bring them out front, flip the thing over. We'll put a little power on that, on those clip leads. See if we can't get the meter to deflect. Just need a little deflection. Now, because I need to be absolutely sure these guys are good. Where's my wire tester? Oh, I've been straightening up my shop so much lately. I've lost track of it. Okay, another way to test these. Resistance. You got to be sure these leads are good. Okay, that's good enough. Okay, very good. So I just heard my phone ding, which means I just got a message from my, from my grandchild. I gotta go check it out. Okay, no problem there. Let's get back to it. Take my flip leads and right across this capacitor. Now, gotta flip this up and over again. The weight is so unbalanced in this thing. Wow. Okay. So I just want to put a little energy into this. I could use a battery, but that would be dumb. Let me use a... Come on in, Peanut. Let's see if this produces, you know, it's on resistance, so maybe this meter is kicking out a little bit of voltage here. You just want to see the movement, the meter move. Everybody watching the meter. I don't see a thing. Oh, there it goes. So what's happening is this is changing scales. Let's flip this around. As this voltmeter I'm using as a just a voltage source, current source, changes scales. 100 ohms. So that proves the movement is good. That means it's well worth continuing on. With trying to figure out why the meter didn't work. So I think we're into full-blown troubleshooting from here on in. This is unplugged. So rather than continue fiddling around with it now, I think my first objective, similar to the other tester, is to get rid of these capacitors and the one up under the meter. Get rid of those. And then maybe test a few of these resistors, but everything looks really good in here actually. Once these capacitors are gone, we'll just test it up again, and we'll start the classic troubleshooting, you know, looking for B plus coming out of the tube, and slowly we'll learn a little more about the machine as we work on it. I see somebody's penciled in H72 right up in there for some reason. I penciled over here 10. Oh, there's quite a bit written in here actually. So before these parts were put in, somebody was penciling in notes. That's a sign that this is kit built, that's built by someone like me. Someone with a lot of patience building this thing. Holy smokes. And then once again, look at all 1, 2, 3, 4. Wow, there's a lot to do in here. But just take it one step at a time, and I'm pretty sure when all is said and done, I'm going to have another excellent tube tester that I'll understand at a very, very good level. So thanks a lot for watching this morning, and we'll carry on with this guy.